Hello guys, my name is Yurii Babich. I am PhD from Odessa National Academy of Telecommunications, and today we're starting the course on Python programming. The main idea of the course is to provide you the knowledge and skills necessary to start writing programs in Python. Since after leaving your lyceum, you're likely to be enrolled at universities, and there you will participate scientific and engineering projects, and there you will be required to write your software. So, why Python? From my point of view, Python is very simple programming language to get started, but it is simple not because it's primitive, but because it is innovative. Now, since you're watching this video, then probably you are interested in software engineering, in becoming the professional in software development. Then, let's take a brief look at the areas of knowledge contributing to your professionality. So, first of all, you should know a syntax of programming language. And we're going to pay attention at syntax during our course. But if syntax is the only thing you know, then you cannot consider yourself as a software engineer, as a programmer. You also need a strong knowledge of libraries and frameworks. So you should be able to select appropriate library for your specific task. You should know the capabilities of frameworks, and you must be able to select the right one for your specific tasks. Then, algorithms theory provides you the knowledge on how to arrange your program in the way to use less resources, how to solve your task in a smartest way. That's why you need the algorithm theory. Architectural principles are also significant because you should write your code in the way that will allow you to extend your code, to add new features, to extend functionality without completely rewriting your code. So, if you stick to architectural principles, then you can upgrade your program easily, and you should know how to do that. Of course, to be a programmer, to be a software developer, you need the practical experience, so write the code, program. And the last area here is the teamwork. So, even if you are a brilliant builder, you cannot build a bridge on your own, you cannot build a multi-floor building on your own. The same goes for software development. You cannot write Windows on your own or Facebook on your own, etc. So usually the software project is carried out by a team of software developers, and you should know how to interact with other teammates, how to share tasks, etc. Now, in our course, we're going to pay attention at syntax, we're going to take a look at some useful libraries, we're going to take a brief look at algorithms and how to solve tasks smartly, and we're going to concentrate on the practical tasks. Now, let's get to the characteristics of the Python. Probably you heard that Python is the high-level programming language, but what actually does it mean? High-level programming language means that you write your program, you write your code without actually keeping in mind the architecture of processor. You don't actually care about operating system, about hardware that your program will be run on. Then, you can use Python for system programming. Of course, you can write system tools and utilities using Python. You can write games using Python, artificial intelligence implementations as well. I have been involved in several projects. There we had to write neural networks, and for those tasks Python was the only choice. Mobile applications and games are also well developed on the Python. You can use Python to develop web applications, and it is highly suitable for Internet of Things. I have been involved in several IoT projects, and those projects were carried out using the Python software. Python is the interpreted programming language. Well, take a look here. Actually, the programming language can be an assembly language, compiled language, or interpreted language. Assembly language is dependent on processor architecture. High-level languages like compiled or interpreted languages are actually not concentrated on the processor architecture. So if you write the program on the high-level language, you don't care about the processor architecture. If you use compiled language like C or C++, then you write a program which is the set of instructions, and then this program is passed to the compiler, and compiler creates binary data file that is equivalent to your program, which is completely different to what happens in the case of interpreted language. Interpreted language takes your instructions, every instruction one by one, string by string, pass it to interpreter. Interpreter translates your instruction to the machine code, and then machine code is executed by the processor. So this approach allows to reduce time necessary for software development, because actually you don't need to recompile your program if you spot the mistake. It's easier to distribute your software in the case of interpreted language, because you can distribute the source code. So, examples of interpreted languages are Python, Ruby, JavaScript. Now, let's start from syntax. Since you're gonna need an interpreter, so where do you get the interpreter? Go to the Python homepage and download the Python for your specific platform, either Windows, Linux, or Mac. There are two versions available, version 3 and version 2. Version 2 is the legacy version, and our course is concentrated on version 3. And actually from these you can see that we are encouraged to use version 3. Version 2 is the legacy version. You can use some third parties integrated development environment. You can use Visual Studio, you can use PyCharm, you can use Command Editor, or you can use small IDE that comes with the Python when you download it. After installing, then you can start writing your programs. Now let's get to the syntax. Now, and the first is the function for getting help. You cannot know everything all the time, so you're gonna need to get help at some point. So to do so, you can use the help function. You can tell that it's function because it contains the brackets. When you see the brackets, then Python invokes the function. Let's try doing so. Let's switch to the Python shell. So this the Python shell. So here we can type our instructions. The instructions are provided to interpreter. Interpreter translates to the machine code, and machine code is executed by processor, and we're getting the result. Now let's try to get help on let's say print function. So here you see the help on the print function. Basically, what the help function does is it reads so-called docstring, or the documentation that can be attached to every object. So this is the docstring of the print function. Now, let's minimize it. Now, it's a good idea to write comments when you write your code, because comments can tell you the idea at some point of the code, or it can ease life of someone who will read the code after you. So, the comments in Python are absolutely simple. The comment is started from the hash mark. If you need to write the code that takes more than one line, you just start every line from the hash mark, or you can use the triple quotation marks, which actually gives you a multi-line string, but you can use it as the comment. Now, the next function we're going to take a look at is the print function. The print function allows us to output what we provide to the function to the file or on the screen. It works like this, so we can print So we have provided a string to the print function, and print just prints out what we have provided into the function. Now let's move on with our syntax. During our course, we're going to meet the following types of data. We're going to meet integer values, float values with a fractional part. We will meet Boolean values, so if statement is true, then the Boolean value is true, otherwise it is false. And we're gonna use strings like we did just 5 seconds ago. Now, here you see how to assign a value to a function. Now let's do that, and let's discuss what actually happens when you assign the value to a function. So let's say a equals 15. It is just simple as that. Now you can check that the value has been assigned to the variable. But you should know the difference, should know how the variables in Python differs from variables in other languages. When you type this absolutely simple expression, what happens is Python creates an object with the value of 15, and that object has its unique identifier, its unique ID, and it has a definite type. Now let's find out the ID. So to do that, we're going to use the ID function, surprisingly. Now let's raise it a little bit. Now this is the ID of an object, and in Python, variable is just the name referring to an object, and that object has the ID, value, and type. So, as you can see, that the highlighted one is the object's ID. Now, let's find out the type of our variable. As you can see, it is integer. Now, let's assign another value to our variable. Let's assign a string to it. So, let's say hello. Now, if we check the content, so we see a string value of hello. Now, let's check what happened with the ID. Let's check the ID of our, or that's probably better, yeah? Or no? Alright, so let's type ID A, and we see absolutely different identifier of an object, which means that now our variable refers to absolutely different objects. So, as you can see, this identifier and that one are different. And the question is, if our variable refers to another object, then what happened to the previous object? So, where is it now? If an object not mentioned anymore in your code, then an element of a Python called a garbage collector clears that object. So, garbage collector with some periodicity clears unused objects to save the memory. So, it's a memory-wise approach. Now, I think you understand the idea of variables in Python and how Python differs from other languages in terms of variables. By the way, in C++ or C, if you try to push string value to the integer variable, it will show error message to you, because you can't do that. But in Python, when you assign new value, you just change the reference. Variable starts to refer to another object, and that is an innovative approach of Python. Now let's consider a simple task. So let's define two variables, C and D, and let's assign values 10 and 20 correspondingly. So you can use the syntax like that to assign the values to variable. Now, and if we check, we see the values. Now, let's consider a simple task. Let's switch those values. So now I want C to refer to 20 and D to be 10. So how can I do in like other programming languages? I'm gonna need at least one intermediary variable to pass those values, or I can use two intermediary variables. How I solve this task with Python? Check it out. We just type cd equals dc. That simple. And now if we check cd, we see that we have switched values. So we have just changed the referencing. So it is that simple with Python. Now I hope you have understood the idea of the variables and how they differ in different Python. Now let's continue with the syntax. So here you see the functions you can use to check the ID of an object, a type of an object. By the way, how to tell it is a function? So if you see the brackets, you can tell it is a function. If without brackets, it will refer somewhere. If it has brackets, then that function will be invoked. So the difference is like you can dial the phone on your smartphone and you can just watch that number. But when you press dial, the call starts. The same works for Python. If you put brackets, then the function is invoked. Now, you can use the following functions to convert between different types. So the int function is used to convert float or string to integer, float to convert to float, string to convert to string format, and you can even use the Boolean function. So let's try it out because it's interesting. So let's find out what is the Boolean of A. So the Boolean value of hello is true. How to make it false? You can do this Boolean, and you can either provide, so yeah, you provide the empty string, and in that case it's gonna be false. Of course you can, let's say, so we have variable c containing 20, and if we check the type of the variables of the object, so it's integer. Now let's make it a float. Float c, and this is the simple way to convert between data formats. When you need those conversions, when you do the operations with variables, because if you do the operations, the type should be the same. Of course, there are some exceptions, like this. Print, like multiply by 2. So you can multiply a string by 2, and that gives you hello, hello. But if you try to, let's say, calculate a sum, let's say if you try doing this, that provides you an error. To do that, you should convert 2 into a string format. So it looks like we're running out of time, so let's meet up after a small break.